Hey there. I thought I would do another video. In case you haven't seen, check out my earlier video where I give an introduction about an operating system that I'm building. The operating system's written mostly in x86 assembly code, so I thought I'd do a bit of a video about what assembly is. So with programming, most people would normally use a compiled language or interpreted language, where instructions are kind of broken down into actual machine code. So the computer needs actual machine code to be able to run. And assembly is interesting in that it's a kind of one-to-one mapping of assembly instruction to a machine instruction. So it's a bit different programming in it, which if you look at the source code, you'll kind of see it's not quite the same. But anyway, it's a good learning experience, I guess, and that's mainly the reason why I'm sticking with it. I do have plans to have other languages in my operating system at some point in the future. For example, you can have C programming in my operating system, which I use for the test suite. So with assembly, it also only targets the CPU architecture that it targets. So each assembly language only kind of targets one machine language. An example of some architectures are x86, which is kind of your normal stock standard computer PC. You've also got like ARM, which is used by like a Raspberry Pi, or probably your mobile phone is using an ARM-like processor. For my operating system, I'm using x86, and in particular, I'm using the 32-bit protected mode. So there's a couple of different modes in x86. There's real mode, which is 16-bit, protected mode, which is 32-bit, and there's also long mode, which is 64-bit. There's a couple of other kind of modes that you can kind of switch between, but in general, that's really all you need to know. Also with assemblers, assembly, you can have multiple different assemblers and they all have kind of different features. The one I use for my project is FASM Flat Assembler, and it has some benefits and some not benefits. They're all just kind of different. Another one could be NASM. You can also have GAS, which is part of AES will do it. And that's part of the GNU project. You also have things like TASM and MASM and YASM. Basically anything with ASM at the end, someone's made a kind of assembler for it. In my case, I'm using FASM, which is a self-compiling assembler, or self-assembling assembler, as it is written in FASM assembly itself, which is kind of cool, and I kind of like it for that reason. Now, with assembly, you don't really have variables like you do in higher level languages like C or Python or Ruby or whatever language you're using, where you normally have basically an unlimited number of variables that you can use to store stuff and then use at some later point. In assembly, you tend to just have a set number of registers. Now in x86, you've got a few different registers. The general purpose ones, I'll pull up a thing. General purpose registers, you've got, how many is it? Like, you've got EAX, EBX, ECX, EDX, and then you've also got ESI and EBI, and ESP and EBP. So these are all the 32-bit modes. You can kind of change this first letter E into an R, and that basically turns it into the 64-bit equivalent. You can also just remove that, and then that becomes the 16-bit equivalent, which can be useful depending on what you're doing and kind of what problems you're trying to solve. For now, we'll just look at the 32-bit ones. So people, you can use these for whatever you want, but in general, people use these for certain values. So like the A register, or EAX, people use as like an accumulator. B, they kind of use it as a base. C is a counter, and D is some data. ESI is like a source register for string operations, and EDI is a destination. And ESP is your stack pointer, and EBP is the base of the stack pointer, which comes into when you call methods and stuff, which we might talk about now, we might talk about it in a future video. I haven't quite decided. You also have other registers that you can't like access directly. EIP, or you've got RIP, EIP, and IP, the 64, 32, and 16-bit modes, and that's your instruction pointer. So that is basically pointing to whereabouts in memory the current instruction is running, and once you execute it, it will automatically go to the next value, which is somewhat handy sometimes. There's like a bunch of other registers, but these ones are kind of what you would call the general purpose registers. There's also a bunch of segment registers. The ones I'll talk about here are CS and DS, which is your code and data. So the code segment is basically it's used as like an offset on certain operations to say this is so like, for example, when you do like a jump instruction, you're saying I want to go to this address in code, and how it actually works it out is it's got an offset, and it uses the CS to compute the actual full memory address of where in code it is. In my operating system, this is just set to 0 at the moment, but it can also be used as part of paging to work out whereabouts you are and what permission you should be running it. Because my operating system just currently runs in what you call ring 0, which is the highest privilege. I don't have paging at all, so I just have this set to 0. When the computer boots up, it will be set to something, and you might have to change it, which in our boot code, which I'll go into in a different episode, we actually do a little trick to set this code pointer code segment back to 0. DS is the data segment, so that's basically when you're trying to load some data rather than jump to some code address, but you're trying to read from memory some data. All right, this data segment is used to kind of work out the correct memory address for it. And again, in my operating system, it's just set to 0. You also have like a flags register, which is called like E flags, and that's got like a bunch of flags that the processor will set after certain operations, and can affect other operations as well. It's got like a bunch of different flags, but some that are kind of interesting are the carry flag. and also the overflow flag. Now the carry flag is when you're doing unsigned arithmetic, so you don't have negative numbers. Once you go over the amount of space that you can have, so say 32 bits, you go over that 32-bit boundary, then the carry flag will get set, and that kind of can get read back by the programmer or the program to then detect any errors and do corrective action. The overflow flag is more for signed arithmetic, and it's basically saying if you have a 32-bit signed number, then you only really have 31 bits plus a signed bit. And when the sign bit gets changed, the overflow bit will also get changed to show that you basically overflown your 31 bits and an error has probably happened. You also have a zero flag, which basically means the last operation had a result of zero, which can be useful for testing certain things or comparing numbers and jumping depending on that. You also have sign flag, which will basically have whether it's signed or not, and interrupt flag, which will say whether interrupts are enabled or disabled currently. And another one that I use in my operating system is the direction flag, and that's used for string operations. Basically, you load stuff into the ESI and EDI, and when you use certain instructions, it will read data from ESI or load data, store data in EDI, and once it does that, it will either increment or decrement depending on what the direction flag is set to. So that's basically a kind of crash course in assembly flags, and just assembly in general. So hopefully this has been interesting to people. Let me know if you have any comments, and feel free to check out my operating system. There's a link in the description, and yeah, let me know what you think, and I guess you'll hear from me at some point in the future in a future video.